Hello, welcome to Dubeke Consult. Our custom here is picking any piece of architectural drawing and we work together to see how we can produce a well detailed drawing that can be applied by the artisans on site. We've been able to transition from producing a general arrangement up to the modeling and pre-analysis phase. And today's lecture will be kickstarting the analysis and design phase. So this is a model we've been working on for a while now. And today we'll get to see how we can design for the slabs at all of this level. All right. If you've not subscribed to our channel, please do so. If you find this video helpful at any point, like it and do not forget to turn on the notification bell so you get notified anytime we post new videos on our channel. Now, designing for our slabs, there are some important checks you need to make. First, you have to ensure you've selected your desired thickness for the slab, and by doing that, let's come back to our plan view. Then we'll click on story 1. We'll start from story 1. On the story 1, we'll come to slab, we'll right click and click on our slab table. So we'll check for our H, this part, and our overall thickness. So you can see these are all 150 slabs, so we are good to go. We'll also check this on our story 2 and other stories. Okay, ensure you do these checks before you go ahead to do your slab design. So we'll check this for story 3 and they are all 150 thickness. And the story 4 as well. So these are all 150 thicknesses. And the only slab at story 5 is as well 150 mm thick. Okay, so now that we are done with this check, we'll come to further checks, which is going to our analysis, building analysis. Then we edit our materials. We want to design these slabs to Y12 only, so we ensure our slab reinforcements are set to Y12. All right, so ensure this is the only one ticked if you are designing to Y12, or it depends on your preferred reinforcement for design of slabs. So this is taking note of Y12 only for our slab design. We'll cancel. Then we'll come back to loading combinations. Ensure the load cases, load combinations are already been predefined before you go ahead to do your slab design. So you do this check as well. We'll close this up. And the next thing is we check your wind and story settings. All right, expand all stories and ensure your notional loads and your wind load has been applied to your structure, keeping in mind that when your notional load and when your wind loads, when they're applied on your structure, they apply as an area load. So they come to the walls, they come to this point, which is the so they come to these walls, which has been predefined earlier during the modeling phase, and this wall will transfer them to your slab, and your slab will transfer them to your beams and your columns, right, before it gets to the foundation. So ensure you've defined your wind and ensure your wind load has been applied to your stories. All right, so the next thing we'll do is we'll come back to our building analysis, and let's allow this project to save. Come back to our building analysis, and we'll move from our pre-analysis tab, then we'll come to our analysis tab. So before we do any analysis, we've not done any previous analysis on this structure. So before we do our building analysis, let's run the building model check to see if we have any slabs that are not supported. We are good to go. All right, so we close this up, then we ensure that building analysis is tick. So you should always run your analysis before you go ahead to do your slab design, so all your reactions, your movements can be accounted for. You tick on building analysis, and for this reason of this class, we will not be designing our columns, we will not be designing for our beams, we will not be designing for our shear walls, just a building analysis. Click on this and we click on start. So we'll allow it to run its analysis. And our analysis has been completed. Then we can check our model and analysis result display later. So let's close this up. We are done with our analysis and let's close this up. We can start designing for our slabs. So to design for your slab, what you will do is come to this part and click on the slab strip, or you come to concrete members and click on your slab strip. Okay, so you click on this and ensure you are designing with, for a solid slab, ensure you are designing with analytical strip. Okay, and we'll be starting on the x-axis. As you know, this is our x-axis, this is our y-axis. So as we'll be starting on our x-axis, so ensure this part is ticked. Now you need to observe the boundary conditions. At your start, what type of slab do we have? Then at your end, what kind of slabs do we have? So at this start, we have a cantilever slab, while at this end, we have a slab that is governed by a beam. And our beam on Prota-Structure at this very slab strip dialog box is denoted by Bob. Okay, so we'll click at the start, we'll click on cantilever, and at the end, we'll click on Bob. Okay, so we'll click this part, hold your control, and we click this. This is our reinforcement Y12 at 250. This is the rebar. This is our top bar. This is the top bar at this is the top bar at this other section. This is another top bar. While these are our bottom bar. Okay, this is the return, which is the top bar. This is the bottom, this is the return. And the next thing is the second slab strip, because you can only run, or you should only run one strip per slab. There's no need to run another strip here. Okay, so run only one strip per slab. So we'll come to the this second part, and we'll click on our boundary condition is starting from a bulb and is also ending at a bulb. Okay, so we'll click on bulb, which is beam, and ends at beam. So we'll click here, hold our control, and so the next is this long spanning slab. It also starts at a bulb and ends at a bulb. So we'll click here, and I really wish one of these slabs can fail, so we can see how to remedy when we encounter issues like that. So for this case, we have a cantilever, and we also have at the start, and we have a bulb at the end. So we'll click on cantilever and bulb. We'll draw our slab strip straight across. Okay, so we are done with this part and this other panel over here. We are still on the x-axis. We come to this other part. At the start, we'll be going with bulb and ending with a cantilevered slab. Okay, so bulb and cantilever. So we'll click here, and we'll click here. The next is bulb to bulb. Okay, so we'll click. So we are designing from our story one. Should in case we have any failing slabs, we can as well remedy that and apply it to subsequent stories. Okay, so we've already run our slab strip on this panel earlier, and the last one is coming from a bulb and ending at a cantilever. So we'll click here, and we take it to our cantilever. All right, so we are done with it. Has provided both our top bar and our bottom bars. Okay, and they are mostly y12 at 250 spacing. So the next thing is we also run our strip, because running your strip for the x-axis is not enough. You also have to run for the y-axis. So we'll come to the y-axis, and for this case we'll be having a different boundary condition. We are starting from a cantilever and we are also ending at a cantilever. So we'll click here and we run a straight slab strip to cantilever to this part, and we have this on the y-axis. Okay, from cantilever to cantilever. All right, and the next one is from bob to bob, from bob to bob, and which is this. The next is we move from here to this part. All right, and for this case we move from a cantilever and we are ending at the bob. So we'll come here, cantilever to cantilever. Okay, because we also have a cantilever here. So cantilever to cantilever, and all right, and for this part is from a bob to a bob. So we'll come here, bob to a bob to a bob. Okay, so this is good to go. And the next one we have our another slab here. So we'll just run this quickly, bob to bob. This should be bob to bob as well. Hold your control, bob to bob, and for this part is cantilever to cantilever, and I really wish one of these slabs can fail. This is bob to bob. Okay, so we'll draw bob to bob over here, and the next one is cantilever to cantilever. Okay, so from this part we'll be taking down to this part. Okay, so we are done with designing our running our slab strip for our story one, and so far we have no insufficient section, but we'll do further checks. We'll do further checks to check for the deflection. You know, some might be very close to the limit of deflection, so we can't monitor the artisans on site when they are constructing. If by chance they slightly reduce the thickness of our slab, will still be okay. So let's come to concrete design and let's design for the slab on this story only. So we'll click on slab analysis and design, and we ensure this all stories is not ticked because we are designing for just one section. So delete and reselect all bars, and we'll click on design. So it will bring out our design reports, and let's view this in a PDF format. Okay, now coming to our calculation sheet, we have to check the deflection limit. Okay, let's look for our deflection check. Now the reason we are doing this is just to account for uncertainties on site. So in case they are constructing and against 150 thickness slab, they constructed 140 just as the case may be. So our deflection check will help us to note the sections that we might get to increase. So if we come here, our one S37, which is a cantilevered slab, so we'll have to look for our deflection check. So L over D, we have 11.05. It's actually sufficient, but if you look at this, this is 11.05 and is less than 11.81. So if you look at these two values, they are very close, and this limit is not advisable. They are very close. This is 11.05 as against 11.81, which is the maximum. If this gets beyond this, then our slab will fail in deflection. All right. So let's come to the second slab. We have deflection check. This is L over D 37.8. So as you can see, this is way lesser than our 52. Okay, this is way lesser than 52. This slab is okay. The next one we have 17.02 is less than 52. So we have a problem here. 11.05 is very close to 11.81 and it's not advisable. All right, so let's come back to, so we'll take note of this slab. This is 1S37. Let's minimize this and come to, we'll cancel. Let's look for that very slab and we'll change the thickness of that slab. So we are still on story one. We'll click on slabs. 1S. Okay, so you can see our 1S37 is our cantilever slab. Remember, this is 1.2 meter cantilever. So this is more reason why we are having we are having a very close limit. That denotes we have to increase the thickness of this slab to cater for that. Okay, so we'll come back to our calculation sheet and let's just have a quick run through on other slabs that might require us increasing the thickness. So for this slab, deflection 17 against, this is okay, against 52 is okay. I think all the slabs that are supported at the edges, their deflection checks are okay, but the ones that are close to the limit should be our cantilevers. So let's check for cantilever. This is support. 1S35 is cantilevered. This is cantilevered. And deflection check, you can see 11.05 is also, this is another cantilevered slab. So 11.05, this is 1S35, is also close to 11.81. In structural engineering, you are dealing with lives and properties, so you shouldn't be in a hurry to just pass your members and be happy that you are done with your design. So ensure you do these checks. Okay, so we'll come back to 1S. This is supported, deflection is okay. So I believe we are having issues with mostly our cantilever slab. Okay, this is also 11.5 against, you can see this one is 11.05 as against 11.08. This is 1S38. Let's look for 1S38. 1S38. All right, so you can see is also a cantilever slab. So that tells us that this 150 thickness we've assumed for our 150 slab, our cantilever slab, due to its length of 1.2 meter is risky. Okay, so what we can do is we can remedy these two, then we'll come back to our design. Let's come to properties, we'll edit this, we can try 175 mm and see the limits. We'll close this and we come back to concrete design, slab analysis and design, and we'll design for this story all over. So we'll view this in PDF. Yes, let's replace this. Then let's search for that very slab, which was 1S37, right? So you can see 1S37, due to our new design of 175 mm thickness, you can see our L over D is 9.13 as against 14. All right, so you can see it's still sufficient, but I think in the previous one we are having something about 11.05 against 11.81. No, that limit is very, very close. So you can see by increasing the thickness of this slab, we can say we are comfortable, or not too comfortable, but this is okay. 9.13 against 14 as our checks. So this is okay. So that in turn tells us that we have to increase the thickness of all these cantilevered slab, okay, and not just on these stories, on every other story. All right. So if you are sure you'll be monitoring the process of construction, you can choose to go with 175 thickness. But for the purpose of design and uncertainties, and also the quality of materials that will be used in construction, since I can't account for that, I will be going with a 200 thick slab for this cantilever. So I will select all these cantilevers, this and this. Then I will not select this because this is not a cantilever slab. What is cantilevered at this point are our beams, while our slabs are supported at three edges. Okay, so this is not a cantilever slab. So these are the ones we should be dealing with. So let's come back to properties. Then we'll come here, column wise edit. We change it to 200 okay, and we close this. So we'll edit with this knowledge that we've had. We edit these slabs on every other story. Okay, so we'll come back to, let's minimize this. Then we'll come back to our story 2. We'll select these two. We'll select this and this. We select this slab and this other slab as well. We come to properties, column wise edit, and we change this to 200 and we close this up. Okay, we repeat same processes for our story 3 and other stories. All right, so I'll be a little faster for time. Okay, all right, so now we are done with editing the cantilever slab on all stories. Let's run another redesign on this story only. We reselect all bars. We'll save as PDF. We'll replace the existing, and let's have our 1s37. So you can see our deflection check. We have 7.78 against 14, and this is very, very sufficient as we've used as we've gone with the options of 250 thick slab. Okay, so with this we are satisfied, and we can apply this same principle since our stories are more like duplicated. So we can apply this same principle on other stories. Okay, so we'll minimize, close this up, cancel. Then we'll come to the next story, which is our story 2. Come to our story 2. We launch our slab strip, analytical strip, and we come to x-axis because we'll be starting with x. Case number 1, cantilever and bob. So I'll be a little faster. Cantilever to bob. So cantilever to bob, and the next one is bob to bob. So we'll come here, draw to this part. We'll come back to this other panel and we'll draw a straight slab of bob to this part. We'll come here. We are starting with a cantilever, ending at a bob. So we'll come here and we stop at a bob. Okay. So the next one is starting at a bob and ending at a cantilever. Okay, so we can, since we already have cantilever here and we have bob here, we can choose to start from this part. Okay, so we can start from here, cantilever, and end at a bob over here. So cantilever and bob, and we have another case of cantilever and bob here. So we'll take this to start and end. Then the next one is bob to bob. We can draw from this direction, bob to bob. That's all for the x-axis, and we'll come back to our y-axis. Our y-axis, we have cantilever to cantilever, so both of this from here to here. The next one is bob to bob. Okay, so we'll click on bob and we'll come down to bob. The next one is bob to bob as well, so we'll click on bob and end at the bob. And next one is this condition to this condition, cantilever to cantilever, so we'll put this here. The next is bob to bob, and we'll put this here. Okay, this is the next bob to bob. Next is same scenario. All right, cantilevered, cantilevered, bob to bob, cantilever to cantilever. Okay, all right, we'll close this, and we'll close this, and we'll minimize and come to the next level, come to the next story, which is we'll come to slab strip over here and come back to our x-axis, cantilever to bob, cantilever, bob, from here to here, our bob to bob. We'll click from here to this part, I will click from here, bob to bob, to this part, and the next one is cantilever to bob. Okay, okay, so now we are done with the slabs for this story. We are done with the slab for this story, and we'll come back to, we'll close this and come back to the next story, which is this last one with a lot of slabs, our story 4. So we use the same principles, we use the same process. Now on our story 4, we use the same process to run our slab strip. So we'll come back to the x-axis, or we can begin this on the y-axis, and on the y-axis we have, as you know, cantilever to cantilever. So this to this. And now we are back to the final story, which is the slab over our shear wall. So for this case, we have just bob and bob both on the x and y axis. So we'll take this on the x to be bob, and we'll take this on the y to be bob. Okay, so now we are done with all of this, and we can now run the comprehensive slab design. Come to concrete design, slab design and analysis. So we'll select and we'll design for all stories. All right. Okay, so you can take out time to go through your slabs and ensure it's sufficient and it meets the required limits of deflection. All right, and always check your L over D to ensure the first value is lesser than the limit. Okay, so you can do these checks on your own, and let's save this and replace the previous calculation sheet. So with this, we've successfully designed for our slabs, and let's check our reinforcements. So we'll come back to story one, and as you can see, we have our top slab because of this cantilever. Remember, if you are designing to keep in mind that if you are designing to BS code, it requires you returning this reinforcement back to this span at uh, L over 4, which is the length of this supporting span, all over 4. Okay, so if you check this is in alignment, that's for the top bar, and this is and we have our bottom bar as well. These are our top bars, these are the bottom bars, this is the bottom bar for this section, this is the bottom bar, this is the bottom bar for this section as well. Bottom bar here, we have our top bar that is going is up to 25% of this section and going 25% of this section as well. Okay, so with this, we've been able to design our slab successfully. If you found this video helpful at any point, please do not forget to like it, subscribe, and turn on the notification bell so you get notified anytime we post new videos on our channel.